Module 1, Lesson 17, Characterize points on a perpendicular bisector. Not a lot of new information in this lesson. We are going to focus on the importance of perpendicular bisectors in our rigid motions, rotations, and reflections. Little bit of vocabulary that we pretty much already know. Perpendicular, lines are perpendicular if they intersect, and the angles measure 90 degrees. Now, the important thing about perpendicular is once you are perpendicular, you can mark a right angle, and all of these angles are right angles. Everybody's a right angle. So if you have one right angle, everybody's a right angle. So it doesn't matter which side you're on there. Segments are also perpendicular if the lines containing them are perpendicular, which makes perfect sense. Now, one of our good friends, the perpendicular bisector, when we are talking about reflections, the perpendicular bisector is the line of reflection. And the important part about this is any point on one side, so our preimage, is the same distance from our line of reflection as its image on the other side of the line. So when we are looking at a perpendicular bisector, let's say for example, line CD here would be our line of reflection, and we would take point A, and if we reflect A across line CD, it ends up at B. And if we look at the segment that connects our pre-image and image, we know that that segment is perpendicular to the line of reflection, and the points are equidistant from the line of reflection. So segment AD is congruent to segment BD, and length AD is equal to length BD. That's just definition of congruence. A review of reflections. Remember that given a line of reflection, if you are on the line of reflection, you stay there. A becomes A prime. If you are not, you reflect over the line, perpendicular, and equidistant. So just a nice little graphic here to remind us of that. The major concepts we are undertaking in this lesson is how perpendicular bisectors are useful in reflections and rotations. In reflections, the perpendicular bisector is the line of reflection, or our line of symmetry, and in a rotation, the intersection of the perpendicular bisectors of your segments that connect your pre-image and image points is used to find the center of rotation. And we will do a couple of our geometry application examples on those. Reminders of our theorems. We talk about these all the time. Perpendicular bisector theorem and its converse say that if a point is on the perpendicular bisector, it is equidistant from the endpoints of that segment. And this is, we use our circles for this, because our point P here, if it's equidistant from the endpoints of the segment, right, we draw our circles because segment PA and segment PB are radii. The converse simply states that if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector. And we use the converse very frequently because of our circles. Anytime we draw a circle, we have two radii that are equidistant from the chord that joins those radii. Remember chord is just a segment that intersects a circle. So a lot of review, but we are going to spend time looking at the importance of perpendicular bisectors in rotations and reflections. Now we have a rotation and we would like to find the center of rotation, so we can use perpendicular bisectors to do that. The first thing we need to do is to connect our image and pre-image points with a segment. I can choose any ones that I like, and now I'm going to use my compass to construct the perpendicular bisector of that segment. I have to be more than half. And then I just move over there, construct my perpendicular bisector, and now I draw my perpendicular bisector. And then I'm going to do exactly the same thing for two other points. So I'm going to choose C and C prime. I can choose any points. Doesn't matter, just need two of them, right? More than half. I'm going to construct my perpendicular bisector and then draw my perpendicular bisector. And where my two perpendicular bisectors intersect, right here, that is my center of rotation, and we will call that point P. So there's my center of rotation. Now what can we say about our center of rotation? We know, one, that it is equidistant from points A and A prime. So we can say that segment AP has the same length as segment A prime P, because that is just a circle that goes through those 2 points. We also have a circle that should go through C and C prime. Let's see if it does. Oh, very nice. And so what else can we say? We can say that segment CP and segment C prime P, so CP has the same length as C prime P. And that would work for B as well. So we could say because those points are going to be equidistant from the center point as well. Now we want to use perpendicular bisectors to find our line of reflection. So we want to know what line these figures were reflected over, so we are going to use perpendicular bisectors for that. And we could use any two image and pre-image points. We could use A and A prime, we could use B and B prime, or we could use C and C prime. It doesn't matter. So I'm going to use B and B prime. Looks like a nice place to work. So I take my compass and I construct my perpendicular bisector. Draw my perpendicular bisector. And this is my line of reflection. We'll call it L. And what do we know about this? Well, we know that the line of reflection is perpendicular to the segment that connects my image and pre-image points. And we also know that they are equidistant. And this is also true for this segment, perpendicular. These two segments are equidistant from the line of reflection, and this is also true for these 2 points, perpendicular, and these points are also equidistant from the line of reflection. So again, perpendicular bisectors, very useful. Now we want to use perpendicular bisectors to reflect a figure across a line. So I start with my compass, and I need to make my segment this time. So I make my compass slightly larger than the line, and then now I have a segment, and I can bisect my segment. I can just go through point A, but we'll just do that so that we can see the whole segment here. Draw my perpendicular bisector. Now the really important part here is I use my compass to measure the distance from point A to the line of reflection. So there's the distance to the line of reflection, and now I'm going to use my compass to measure that distance again. Mark my distance there, and this point becomes A prime. Now I'm just going to repeat this process for point B. Make it a little bit longer than the segment. Now I have a segment that I can use to bisect. Now I'm going to draw my perpendicular bisector. And then the most important part, use my compass to measure the distance from my point to the line of reflection, and then measure from the line of reflection to my image point. So this point becomes B prime. And we know that C is on the line of reflection, so C just becomes C prime. And now I can construct my image. And I reflected across that line. Now what do we know about this? Well, we know that the segment from A to A prime is perpendicular to the line of reflection, and the distance from A to the line of reflection is congruent from A prime to the line of reflection. It's all same for our segment that goes from B to B prime, perpendicular to the line of reflection, and our two pieces are congruent. So just like our previous construction that we did, this is just going backwards. So perpendicular bisectors are extremely useful when we're doing rotations and reflections.